Welcome back to the deep dive. It is Saturday, February 7th, 2026.
Wow, already.
I know, right? And usually the start of a year is kind of a slow ramp up. You set some resolutions, you ease back into the workflow.
Right.
But looking at the stack of reports and mission updates we have here today, I honestly don't think I've ever seen a velocity of events quite like this.
No, it's dense.
We're barely 5 weeks into 2026, and the sheer amount of news is, well, it's a lot to get a handle on.
It really is. And I think the whole texture of the news has changed. For the past decade, it's been all about launch cadence. How many rockets, how much mass to orbit.
Exactly.
But if you look at our sources for this deep dive, NASA updates, corporate filings, even research papers from just a few days ago, the metrics shifted. It's not just about getting there anymore.
So what is it about?
It's about integrating intelligence AI and heavy industrial infrastructure directly into the void.
That's the vibe I'm getting. We're not just visiting space anymore. We're moving in. And we're bringing our biggest computers and our heaviest tools with us.
We are.
So the mission for this deep dive is to give you a definitive State of the Cosmos update for the first quarter of 2026. We're going to try and synthesize these massive shifts in human spaceflight, this wild trillion-dollar merger, and some discoveries that are basically rewriting the textbooks as we speak.
It is a perfect storm. You have this massive corporate deal that could change the digital economy happening at the exact same time JWST is solving mysteries about the dawn of time.
And while all that is happening, we have actual human beings sitting in quarantine right now, literally counting down the hours to launch.
Yeah.
So let's unpack it. We've got little red dots, robots driving themselves on Mars, and a deal valuing a space company at over $1 trillion.
A lot to get through.
Okay, let's start with the human element, because for all the talk of AI and robots, we're on the verge of the biggest step for humanity in over 50 years.
You're talking about Artemis II?
Yeah, I'm looking at the status update. It feels like we've been talking about this mission forever, just waiting for the hardware to finally be ready.
It does. And it's easy to get cynical about all the delays. I get that. But we have to ground ourselves in what's happening right now. As of January 19th, that Orion spacecraft is physically sitting on top of the SLS rocket at the launch pad.
So it's real. Not a rendering.
Not a rendering, not a PowerPoint slide. It is real hardware standing there waiting to take 4 humans around the moon.
And the timeline, is it actually holding this time?
It's getting very, very tight. They're targeting a launch no later than April. So we're talking about a window opening in, 8 weeks or so?
Okay, for anyone who might have tuned out during the delays, what's the actual mission here? Are they landing? I think some people are still a little fuzzy on that.
No landing yet. This is a 10-day flyby. Think of it like a shakeout cruise for a new ship.
A test drive.
Exactly. The whole goal is to stress test the life support, the navigation, the radiation shielding, but with a living, breathing crew on board. It's the final exam before they even attempt a landing with Artemis III.
So they slingshot around the moon, go deeper into space than anyone since Apollo, and then come home.
That's the plan.
It's surreal that it's actually happening this quarter. But, okay, while Artemis is prepping on the pad, we have more immediate action in Florida with Crew 12.
Right. This is the daily commute, so to speak.
It really is.
As of February 2nd, the Crew 12 astronauts are officially in their 2-week quarantine. They're locked down to make sure they're perfectly healthy for the trip to the ISS.
Now, I did see some worrying headlines about their ride. The Falcon 9 was grounded. That doesn't happen very often.
Briefly, yes. There were some issues with the upper stage that triggered an FAA investigation. And you have to remember, SpaceX has had a few of these upper stage hiccups in the last year and a half.
So the FAA paused things.
They did. But just yesterday, February 6th, the FAA officially cleared the Falcon 9 for flight.
So it's greenlit.
It is. They're now targeting February 11th for launch. So in just 4 days, another crew heads to the station. It really shows how resilient the system is now.
Right, a grounding that lasts just a few days instead of, months or years like in the shuttle era. Speaking of eras changing, we have to talk about the leadership shift at NASA itself. We've got Jared Isaacman as the new administrator. This feels like a radical departure.
It's a massive pivot. I mean, historically, NASA administrators are former senators, politicians, career bureaucrats.
Right.
Isaacman is a commercial astronaut. He's an industry leader. He's flown private missions. He's commanded them.
He funded Polaris.
Exactly. Bringing that private sector mindset into the top job signals a much deeper integration between the agency and the commercial world.
So it's less government versus private and more of a hybrid model?
It seems to be. And as he's stepping in, a legend is stepping out. Suni Williams retired on January 22nd.
After 608 days in space?
That number is just staggering.
It really is. That's nearly 2 full years of her life spent off-planet.
And her career is the perfect bridge. She flew in the shuttle era, the Soyuz era, and the commercial crew era. Her retirement really feels like turning a page.
Yeah, the old guard passing the torch to a new generation.
A generation that's probably going to be working on the moon.
Okay, let's pivot. Let's talk about the news that, it basically broke the financial internet this week. We're calling this segment the Silicon Vacuum.
This is the blockbuster deal.
For sure. On February 2nd, SpaceX acquired XAI, just swallowed it whole.
In an all-stock transaction. And the numbers they're just eye-watering. The combined valuation is sitting at $1.25 trillion.
$1.25 trillion.
Yeah. That's SpaceX valued at $1 trillion and then XAI at roughly $250 billion.
So we have the biggest rocket company buying a massive AI company. Obviously, Elon Musk is the common thread. But what's the strategic logic here? Why does a rocket company need a large language model?
If you dig into the filings, the why isn't about better chatbots for astronauts. It is explicitly about infrastructure. The goal is to create space-based AI data centers.
Putting the server farms in orbit. But wait, isn't that incredibly difficult? You've got radiation maintenance issues.
Yeah.
Why move the data center away from the engineers?
It comes down to two bottlenecks we're hitting on Earth right now: power and heat. AI compute just eats electricity, and it generates a ridiculous amount of heat. On Earth, you need cooling towers, massive water supplies, a connection to the grid. In space, you have uninterrupted solar power.
And the ultimate heat sink.
The vacuum of space.
But hold on, isn't a vacuum an insulator? Like in a thermos, won't the servers just melt?
That's the common misconception, and it's the really tricky engineering problem. You can't use fans. There's no air. But you can use radiative cooling.
So just beaming the heat out.
Beaming it out as infrared radiation into the blackness of space. If you can solve the engineering for the radiator surface area, you basically have infinite cooling capacity without using a drop of water.
That's fascinating. So they're moving the compute off-world to solve an energy problem on Earth.
That's the vision. It shifts SpaceX from being just a cosmic trucking company to being an orbital computing landlord. You're not just paying for the ride up, you're paying for the processing power that lives up there.
And it seems this whole AI and space thing isn't just a future plan. It's happening right now. I saw a headline about the Perseverance rover.
Yes, this was the same day as the merger announcement, February 2nd. Perseverance completed its first-ever drive on Mars planned entirely by AI.
So what's the difference? How did it work before?
Well, before, human rover planners on Earth geologists, engineers, would meticulously map out every single meter the rover would travel.
To avoid rocks and sand traps.
Exactly. Then they'd beam the instructions up and the rover would just execute them blindly. It's incredibly slow and painstaking.
Because of the 20-minute communication lag.
Exactly. You can't joystick it in real time. But now, the rover is using its own vision and AI to analyze the terrain, spot hazards, and plot its own route. It's truly autonomous exploration.
So we're taking the training wheels off the robots.
We have to. This is so crucial for future missions. When we go to the moons of Jupiter, the lag isn't 20 minutes, it's over an hour. The robots have to be smart enough to survive on their own.
We're giving them agency because we're too far away to help. Speaking of AI helping us see better, I read about something called Amigo.
Right, the AI software for the James Webb Space Telescope.
What does that do?
It basically acts like corrective lenses. It fixes image blurring in some of the instruments using software, restoring crystal clear vision without needing a physical repair mission. It saved a multi-billion-dollar instrument from being nearsighted.
Which is a perfect segue to what JWST is actually seeing, because while the business guys are merging companies, the astrophysicists are rewriting the history of the universe.
Yes, they are.
Let's talk about the little red dots.
This was a mystery that's been bugging astronomers for a couple of years. JWST kept seeing these faint, red smudges in the very early universe. They didn't look like normal galaxies or quasars.
And now we know what they are.
As of mid-January, yes. And it's startling. They've been identified as young black holes hidden in dense gas clouds. But here's the kicker. They are way too massive.
Too massive for what?
Too massive for their age. Standard theory says black holes grow slowly over billions of years. But these things, which we're seeing shortly after the Big Bang, are already giants.
How is that possible?
Well, the evidence now points to a theory called direct collapse black holes, DCBHs.
Meaning they skip the whole being a star first part.
Exactly. The idea is that massive clouds of primordial gas collapse directly into a black hole. It's like finding a toddler who's already 6 feet tall. It just breaks the timeline of how we thought the first massive structures formed.
Wow. Okay. And speaking of invisible structures, on February 3rd, we got a new map of dark matter.
The most detailed one ever produced,
Why does a map of something we can't see even matter?
because it's the scaffolding of the universe. Dark matter's gravity is what pulled regular matter together to form the very first galaxies. This map confirms that this invisible web was in place long before the first stars ever lit up.
It's the cosmic blueprint.
It really is. And on that same day, February 3rd, we got GW2501114,
A gravitational wave detection.
and a record breaker for clarity. It's the clearest signal we've ever had of a black hole collision. It lets scientists put Einstein's general relativity to a really rigorous test.
And did he pass?
So far, Einstein remains undefeated. The theory held up perfectly.
He usually does, but JWST isn't just looking at black holes. Yesterday, February 6th, there was a report about the building blocks of life.
In a nearby galaxy, yeah, it found unexpected chemical complexity. We're talking about complex organic molecules. The precursors to life in abundance is far higher than our models predicted.
So the ingredients might not be so rare after all.
It suggests they might be common throughout the universe.
That is hopeful. Okay, let's bring it back home for our last segment. Infrastructure and geopolitics. Because we're trying to figure out how to sustain life on our own moon.
And specifically, how to power it. This is where things get a little tense. We have to talk about the nuclear directive.
This came out last year, but it's really heating up now. What's the push for nuclear?
The directive is to fast-track a 100-kilowatt nuclear reactor on the moon.
Why not just use solar?
Solar is great in orbit, but on the surface, especially at the South Pole where the water ice is, you get periods of darkness that last for 14 Earth days. You need baseload power that runs 247.
But this isn't just an engineering decision, is it?
No, it's explicitly geopolitical. The sources say there are major concerns that China and Russia are planning a joint reactor by the mid-2030s.
And why does it matter who gets the plug socket there first?
Because of keep-out zones. The fear is that if a rival sets up a high-power source, they could effectively claim the surrounding resource-rich area for safety or operational reasons. Energy is currency on the moon.
Which explains the push this year to finalize coordinated lunar time.
Right. You can't run a power grid or avoid collisions if everyone is on a different clock. It sounds boring and bureaucratic, but it is absolutely essential infrastructure.
So the moon is becoming a very busy construction site, but where do people live? The radiation is a huge problem.
That's where the lava tubes come in. Just this week, new mission concepts were released, involving robots designed to descend into these massive caves on the moon and Mars.
These are natural shelters.
Exactly. Tunnels left by ancient volcanoes. They offer natural shielding from radiation and micrometeoroids. It's way easier to seal a cave than to build a bunker from scratch.
So we've got reactors, lava tube habitats, time zones, but there's a flip side to this. Boom. Some sobering news out of the UK.
Yes, on February 6th, a proposal to cut UK government funding for astronomy and physics by 30%.
30%, that's a massive slash.
It is. The researchers are calling it disastrous.
Okay.
And it really highlights this divergence. You have the commercial sector raising trillions and pushing ahead, while traditional government-funded science, in some places, is contracting.
It feels like the balance of power is shifting.
It does, away from national science programs
Yeah.
and toward these mega corporations, unless it's tied directly to geopolitics.
So to wrap all this up, Q1 2026 isn't just more of the same.
No. If I had to sum it up, I'd say we're witnessing a convergence. Heavy industry, like nuclear power, is meeting advanced computing, like AI data centers, all happening within the domain of deep science.
Space is no longer just for observation.
It's becoming an active economy. It's not just a lab anymore, it's a factory and a server room.
Before we go, I have to throw in this fun fact from the archives because the timing is just perfect.
I think I know where you're going.
Yesterday, February 6th, was the anniversary of Alan Shepard playing golf on the moon in 1971.
The famous 6-iron shot.
Yeah.
Miles and miles and miles.
It's just wild. In 1971, the pinnacle of our achievement there was hitting a golf ball. Today, on that anniversary, we're talking about building nuclear reactors and AI data centers on the very same ground.
We have come a very long way.
But this whole deep dive raises a pretty big question for everyone to think about. We talked about the SpaceX and XAI merger. If we really do move our most powerful computers into orbit, if the brain of our digital civilization is floating above us, How does that change the power dynamic down here on Earth?
It's the ultimate high ground. If the intelligence is in orbit, who controls the uplink?
Something to think about. That's it for this deep dive into the state of the cosmos. Thanks for listening and keep looking up.
See you next time.